In this section, we're going to be covering the three different trig functions. There are sine, cosine, and tangent. We have three triangles that are drawn here that represent ways of solving for side lengths within a right triangle using these three trig functions. The first one that we're going to look at is sine. The trig functions have an anagram known as SOHCAHTOA. Okay, we talked about SOHCAHTOA in class, and the S, O, H in the SO part represent everything that has to deal with the sine function. The sine ratio is opposite over hypotenuse, which is why we have O and H here. Opposite over hypotenuse. The CAH is the cosine function, which is adjacent over hypotenuse. And then finally, the tangent is the opposite over adjacent. So we have SOHCAHTOA. So if we look at our sine problem, we're going to be using the sine function to solve for x. So we always start out our trig problems by using our trig function, in this case which is sine, and then putting down what angle measurement we will be using, which is 50. Then we set that equal to whatever the ratio is. My sine ratio is opposite over hypotenuse. I take the angle measurement, and the opposite side from my angle measurement goes in my numerator, and the hypotenuse goes in my denominator. So this would be x over 20. I will solve this algebraically just as if this sign wasn't here. If I had 50 equals x over 20, we would multiply both sides by 20 in order to isolate x. So that's what we will do here. We will multiply both sides by 20 so that we can eliminate the 20 on the right side and isolate x. So in my calculator, I will do 20 times the sine of 50, and when rounded to the nearest tenth, I will get 15.3 as being my value for x. Now when I do cosine, the main difference in these two triangles here is that next to my 50-degree mark is where my x is on my cosine. So this is the adjacent side. So you can see how these are both illustrated and how they are different in terms of what I'm solving for. Sine will allow for me to solve for the side opposite the angle. Cosine will allow for me to solve adjacent to the angle. I will set it up to where it looks the exact same. Cosine of 50 is equal to x over 20. The only difference is now I'm using cosine. This function will produce a different number when I find the cosine of 50 than if I found the sine of 50. I'll still do the same thing of multiplying both sides by 20 in order to isolate my x value. And if I do 20 times the cosine of 50, rounded to the nearest tenth, my answer will be 12.9. So that will be my value for x. As we move on to tangent, the main difference with the tangent ratio is that I have no value in my hypotenuse at all. There's nothing here. No side length given. At that moment, I know that I can use my tangent ratio to find my different side length if I have opposite over adjacent, just like it says here in my anagram, SOHCAHTOA. So I will set it up again the same exact way I did sine and cosine. The tangent of my angle measurement, 50, is equal to 20 over x, opposite over adjacent. Now, also in class we talked about how the property of if A equals B over C, then C equals B over A. And we gave the example of if 2 is equal to 6 over 3, then that means that 3 is equal to 6 over 2. I just flip-flopped what was to the left of the equal sign in my denominator. So I can do the same process here if I have x in my denominator of my ratio. So I can say that x is equal to 20 over the tangent of 50. And then I can find my value for x. So 20 divided by the tangent of 50 would give me 16.8 as my answer for x. And that would be my value. Now I could have also used the tangent of 40 here, because I know that all three of these angles need to add up to be 180. So if I have a 90-degree angle here, that means I would have 90 degrees more between these two angles, and that if this is 50, this would be 40. So I could say the tangent of 40 equals opposite over adjacent, x over 20. And I would still come up with this same 16.8 answer. So now what I want you to do is pause this and create three triangles of your own that use all three of these trig functions, just like I did. Use different numbers, use different angle measurements, and go through and solve for each one of those three triangles. The second part of this is going and finding the angle measurements, knowing the side lengths. So I'm going to show you how you can use sine, cosine, or tangent to solve for A or B in this triangle. In this triangle, I have the side lengths of 12, 16, and 20. Let's say that I wanted to solve for angle A. So I wanted to find the sine of whatever A is. I'm using the inverse of sine in order to find this angle measurement. I'm still going to set it up using the same ratio. So I know that sine is opposite over hypotenuse. Well, here's A. The opposite is 16. The hypotenuse is 20. So that's 16 over 20. If I was to use cosine to find A, cosine is adjacent over hypotenuse, or 12 over 20. If I was to use tangent, I would do opposite over adjacent, or 16 over 12. And I would find the tangent of A using 16 over 12 as my ratio. Any one of these calculations that you put in your calculator will give you the exact same answer for the angle measurement for A. In your calculator, in order to find the angle measurement, to use the inverse, you need to press second sine 16 divided by 20. And that would give you 53.1 degrees. Second cosine 12 divided by 20. 53.1 degrees. Second tangent 16 divided by 12. 53.1 degrees. It's the same exact angle measurement, just using the different ratios. So you can come up with these same exact answers as long as you are using the correct ratios here. That's the main key. So that is it over the sine, cosine, and tangent functions and their inverses. A lot of the problems that you will be seeing will be word problems dealing with this, especially on the EOC. So a lot of the work that you're going to be seeing on your test, a lot of the problems, and on your assignments will be word problem based.